Welcome back to lesson 6-4. We'll be talking about slope-intercept form and what that looks like when you have an equation of a line in the form y equals mx plus b. And yes, those are variables, mx plus b, and we'll talk about the different parts and which one represents slope and how you get the equation of the line in a table and a graph. So this is kind of fun. This is something new. So everything you're doing with slope in this section is new to you. So stuff that you have to stay up on, and you've got to make sure you understand the vocabulary. Okay, so linear relationships can always be written in the form y equals mx plus b. And so you see that when you see an equation. You don't know what the parts are, we're going to talk about it. So this is called slope-intercept form. When you're taking your STAR test and you get your table of, not table of contents, sorry, your STAR reference chart, and you're looking on it, you'll notice that on your STAR chart, the very first thing that's listed at the top is slope-intercept form y equals mx plus b. So this is given to you. It also talks about your constant rate of change y over x, or change of y over x, which is also your slope, also called your constant of proportionality. And so that's in here as well. So it's not like you're having to memorize these things when you take your test. But let's continue to go through it. But when you write the equation, it's written in the form y equals mx plus b, and m represents the slope and b represents the y-intercept. So anytime you see an equation written in this form right here, your m, and I know this is crazy, why didn't they just use an s, is referred to as slope. Well, mathematicians that discovered linear equations got to name these things, so we get to give them credit for that. The b is going to be called your y-intercept, and that what that means is when you're looking at the axis y up and down, where does b tell us we start? So wherever that point is, that's kind of the starting line. The slope will either be negative going this way or positive going this way, but it will always travel through b. And b could be 0, it could be positive, it could be negative. And we're going to show you how that happens on the linear equations. The y-intercept we just talked about, that's the line that crosses the y-axis. And the slope is, of course, your constant rate of change. In the linear relationship, it is the steepness of the line, how steep it is. And it is also called your rise over run. And you should have this down by now, delta y over delta x. So these are just some of the ways that we can write our slope right here. Rise over run, delta y over delta x. So in this first example here, the equation was given y equals 4x minus 10 right here. And all you have to do is name the parts. So it's a pretty simple lesson today. It's just getting you used to where slope is and where y-intercept is. Slope is always your m. So when we talk about y equals mx plus b, that's the equation set up, the linear slope-intercept form for linear equations. The m is your 4. So that's my slope. The negative 10 is my b. Now notice they put plus negative 10 because you can keep change, and that would be plus a negative 10. But honestly, you should just look at this as a whole value. It's negative 10. And so what that means is that if I were to graph this line just a little bit, and I'm just kind of freehanding this, that means I would travel down to negative 10, and I'm just going to skip jump here. That's going to be my start value on my y-axis. So there'll be actually a point at 0, negative 10. That's what that's saying. That there's going to be a point, and I'll write it under here under y-intercept at 0, negative 10. Okay, and that's where it's going to cross, the line's going to cross the y-axis. And then from there, it's slope. It's going to be rise over run. So slope is 4. It's better to put it as a whole number, but this is going to, of course, be rise of 4, run of 1, because 4 over 1 is equivalent to 4. So you would have to rise 4 and then run 1, and then rise 4 and then run 1, and continue that pattern in both directions to create your line. Okay. And so I'm just freehanding this. The numbers aren't exact, but you can kind of get an idea of what's happening. So let's look at example 2. Use the slope-intercept form to graph the linear equation y equals 1/2 x plus 3. So what we do is we first decide, okay, where does it hit the y-axis? And that's this +3. So +3. So 0, 3 is where it hits the line. Then our slope is 1/2, which means rise 1, run 2. So from here, you rise 1 value up and run 2. And that's when you hit this point. Now going the opposite direction, I'd rise -1, run -2, go backwards. Rise -1, run -2, because a negative over a negative is a positive. So understanding that this slope is the same as this slope, but this is the simplified version, but they still mean the same thing, allows me to draw my points going either direction and connect them. And I play connected dots. So pretty easy to graph it once you know which part's slope and which part's your y-intercept. So on your classwork in class, you're going to be practicing just which parts are slope and which is y-intercept. So we're going to put M and we're going to practice M is slope. And where is slope? It's next to your X value. It's your changer. That means there's a rise of -5, a run of 1. And this line will be sloping gently negatively, actually pretty steeply, sorry. The bigger that value is, the steeper the slope is going to be. And just a reminder, slope guy, he should be your best friend by now. Just need his eyes and his eyebrows. Positive slope, negative slope. So we have our slope, and now we need our y-intercept. And we don't put y, we put b, because b is the letter that represents it. And that's where you look at the back, and b is -1. That means that the equation of the line is going to hit the y-axis at 0, -1. This is what it's referring to right there, okay? When it says y equals -x, you say, well, what's next to the x? Well, how many x's are there? There's 1. So writing -1x is the same thing as writing -x. So my slope here is -1. And notice I'm not writing these as fractions. This could be -5/1, but I don't need it. This is -1/1, but I don't need it. These are the simplified versions of those slope. And I know that the run is going to be 1 if there's not one shown. So that's my slope, my b. And if you notice, there's not plus or minus anything here. So be plus a 0 or minus a 0. Therefore, this graph is traveling through the point of origin 0, 0. So if you don't have a plus or minus and all you have is an x value, all you have is slope, it will be traveling through the point of origin. It will be proportional. Some people forget what proportional means. Proportional means any line that travels through 0, 0. That's why the word proportional has the 2 O's in it to help you think about that. Proportional. So this one's proportional. This one's not going to be proportional because it starts at 0, -1. It doesn't travel through the point of origin. Over here, we have a slope. It's attached to the x. It's -2/3. My b is whatever's attached to it, plus or minus. And it looks like it says +8. So it's going to be intercepting at the point 0, 8. Okay, over here, slope. Now here's a situation where the y is not by itself on the left. It's not in slope intercept form. And so I really should get it in slope intercept form, except for if you notice this is -4x, the slope is -4, it's just in front of the x. It should be on the other side. And that's where it changes it. Is it really a -4x? So we say, uh-oh, we think it is, but it's really not. Because when you're solving equations, you have to have y by itself. So you're going to add 4x to both sides to solve the equation. And you get y equals, and this is going to go to the right-hand side, 4x plus 6. So this one's a little tricky. You have to do a little equation work. You have to isolate the variable y by itself. So the opposite of subtracting 4x is adding 4x to put it on the other side. And so you wind up with 4x plus 6. So the slope's not negative, it's actually positive. And the b, or the y-intercept, is plus 6. So it'd be 6. So my ordered pair would be 0, 6. Tricky, tricky problem. Watch yourself on that one. Use the slope intercept form, which is y equals mx plus b, and we're going to graph it. And we say, okay, well, all I need is the slope and the y-intercept. If I have those two things, you can graph anything easily. So the m of slope is attached to the x. So what's attached to the x? A -2. So that's my slope, or negative, or you can think of this as -2/1 like we've talked about. And my B is my y-intercept, but there's no plus or minus anything. So this, or a zero point of origin, will be my y-intercept. So I start my y-intercept at 0, 0, and I'm going to go down to 1, 2, and right 1. It says down to 1, 2, and right 1. The opposite would be up to left 1, up to left 1, and it goes opposite the other direction. And if you notice, it should be negative slope. If it's not negative slope, you've done something wrong. It has a -2, it's negative slope. Fairly steep, but not too steep. If you notice over here, -3x, this slope will actually be steeper than this one. So we're going to say slope over here. What's attached to the x is a -3, so that's my slope. My b is at 1, so my ordered pair would be 0, 1. And so I go 0 and up 1. It's going to start there on the y-axis. It says I'm going to go down 3, 1, 2, 3, right 1, down 3, right 1, up 1, 2, 3, left 1. So I have a down 3, right 1, down 3, right 1, down 3, and you can see the stair steps happening. It is a linear relationship. It is not proportional. This one, however, was proportional, traveling through the point 0, 0. This one was not. And so what effects does it have? And you can see this line's a little steeper, is that if this would have been a -2x plus 1, they would have been the same line parallel to each other. It just would have shifted up 1. And so this back value, this b, is shifting my line up and down. The slope is what makes the amount of change, the rise over run. So these are the types of problems you'll be practicing with. Please, a reminder, if you have any questions, to please message or text me and let me know so I can help you out. Y'all take care.